Here we go with example 2, part D. Again, we have a definite integral, so we're about to apply fundamental theorem of calculus here, and we need to integrate this thing. We got a power on a group. Let's do the chain rule. There is no such thing for integrals. We've got to be able to do some algebra to this. All right, one thing that I would hope would happen would be that our instincts tell us when we're either going to differentiate or integrate a function that we change radicals into fractional exponents. I would recommend doing that, x to the 1/3, and then we've got the squared out here. All right, let's see. Oh, let's just drop that squared on the 2 and on here, and boy, that'd be easy, wouldn't it? You're killing me, Smalls. You can't do that because of this. That's algebra. You can't drop a power over addition or subtraction. It drives every algebra teacher crazy. Crazier. Can't do that because of the addition. All right? So, wah, wah. People try to make things too simple. All right? What we need to do, because of that addition, is write that group out twice, which is not a big deal, and distribute it. And if we speak English, first outer inner last FOIL. And if we speak Spanish, it's PEIU, I'm pretty sure. Primero, extremo, interior, ultimo. I don't speak it very well. Sorry for my mispronunciation. But anyway, first, 4. Outer plus 2x to the 1/3 power. Inner plus another 2x to the 1/3 power. In the next step, those are going to be like terms, aren't they? All right, plus, oh boy, what do you do when you take x to a power times x to a power? What do you do with those powers? Anybody? Anybody? Yes! Who said that? Yes. Yes, you add them. So 1/3 plus 1/3, that's going to be 2/3. So, I think we're ready to transfer that over here. Wouldn't that translate into 4 plus, these are like terms, 4x to the 1/3 plus x to the 2/3 dx. All right, so much like when we first learned derivatives, we said we got to be able to take these expressions and do algebra to them to make them terms with powers. And that'll work so far. That's going to change. But anyway, this is just algebra. Then, how many times have we said that the majority of these questions are algebra and arithmetic? All right, so anyway, now we go through. Now this is where the calculus is going to happen, right? And I guess it's been a while since we've put it up here, but wouldn't the link be back to the power rule here, whereby, again, we do n plus 1, n plus 1. What's the integral of 4? What was that you asked? With respect to what variable? Good question. With respect to x. Oh, that would be 4x, wouldn't it? Good job. You remember to ask me that question. All right, plus 4x. Let's see, what's 1/3 plus 1? That would be 1/3 plus 4/3. And then over 4/3. Oh, wait a minute, over 4/3. That's the same thing as times 3/4. Let's get used to doing that. Plus x, n plus 1. What's 2/3 plus 1? 2/3 plus 3/3. 5/3. 5/3. And instead of putting that over 5/3, that's the same thing as times 3/5. Invert and multiply. That's just arithmetic. And then integration has been performed. So therefore, we transfer this over to the evaluate symbol. That's I don't know the technical name for it. That's what I like to call it, is the evaluate symbol. So again, what we're talking about here is after we find the antiderivative, this is the math symbol that tells the viewer, now go stick the numbers in. All right, I'll go one more step with you on this one. I'd clean it up a little bit. I noticed, for example, here, 4/1, and wouldn't that be, oh, 4's canceled. 3, forgot my plus sign, sorry, plus 3x to the 4/3 plus 3/5 x to the 5/3, and this is going to be evaluated from 1 to 8. Okay, you know the drill. You guys told me a while back that it's fair for me to go, stick the 8 in, and that would be this one. Then minus, stick the 1 in there. And it's just arithmetic after that. And it turns out that that will be 91.6. Okay? And I understand I skipped some arithmetic steps, but I hope you're clear by now. Stick 8 in there and crunch it out. Minus, stick 1 in there and crunch it out. And do them in their entirety. Get the entire value for 8, get the entire value for 1, and then subtract them. What a snob that guy is. That part of it is just arithmetic. All right, we'll go on to one more idea in this section.